We also have a pretty extensive respiratory protection program on campus. Just like we have to protect people's eyes, we have to protect people's lungs from a variety of things. The same sorts of things that we protect them from by giving them eye protection. Dust, mist, vapors, flying objects, biologicals, okay, gas to some degree, okay. But respirators are a device you put on somebody to keep them from inhaling a contaminant that they don't need to be inhaling. Make sense? Okay. There's two basic types of respirators. One is just a mask you put on your face and you breathe through that filters stuff out of the air you're breathing. The other is one that you take air with you. How many of you have seen the movie Chicago Fire or Backdraft, those movies? Anybody seen scuba divers? Okay. That's what we're talking about there. They take the air with them. Those are called self-contained breathing apparatuses. Okay. In my line of work, we commonly refer to those things as Scott Air Packs. That's just a generic sort of thing because that company was first to make some of these things. And when we do training for people who need respiratory protection, we try to make sure they understand that the two basic, most bottom line requirements for safe respiratory protection use is that the respirator fits the person's face and is effective against the contaminant they don't want to inhale. Make sense? Everybody who's required to wear a respirator has to have a fit test. I mean, we put them in a little tent, wave a pretty nasty tasting or nasty smelling chemical around. If they don't smell it, taste it, we know we got a good fit. If they taste it, smell it, that tells us we got to change to some other type of respirator, some other model, whatever, because it's not working. When I train people, I tell them I'm going to do everything I can to make you fail a fit test. Now, why might you think I tell them I want to make you fail your fit test?
Worst case scenario.
Okay, and what might that worst case scenario be? You might inhale something you don't want to inhale, right? Why else might I tell them that I want to make them fail a fit test?
Make sure it fits right.
Speak up, you got it.
So you make sure it fits right.
Mm-hmm. So make sure it fits. If it doesn't fit, it's useless. And again, we're talking about biologicals, we're talking about chemicals. People don't need to be inhaling. And they have to be approved for what use they're being incorporated. Okay? You might need to wear a respirator down here, especially if you're chopping up whatever you're making down there in testing, because you might, when you're mixing cement, okay, if you're mixing especially Portland cement, you should be wearing a respirator. Keep from inhaling Portland cement because it's got a lot of silica in it. And silica is a nasty item to be inhaling. If you know anything about asbestos, asbestos is a silica-based compound. So you don't want to be breathing silica. There's one type of respirator. This is the air filtering kind. You probably see these in Lowe's, Home Depot, True Value, Ace Hardware, all that sort of stuff. This one is what we call a multiple-use respirator with replaceable cartridges for specific chemicals. There's a couple examples of the supplied air type. This Scott Air Pack is not a light piece of equipment. It can be cumbersome, especially if you got to go through narrow doorways or crawl on the floor. It can be a pain. This is called an airline respirator. You put the pump out in a clean air area, put on the mask, and go to work. But you got to drag that hose around. Those are the two basic types of supplied air respirators. We'll click through this real quick. People in my line of work much prefer to engineer a problem out. If we could set that lab up down there so you could do everything robotically, and you be in a little control room like this room over here, that would be ideal because you would not be exposed to anything that might pop up down there in the strength lab. Everybody follow me? Sometimes we can't do that. We can't set up robots or barricades or glove boxes, and we have to do something else. If you have people who are exposed to a hazard, you might be able to cut their exposure in half by dividing the work up. Say this young man here in the register, your name? Dylan. So we find Dylan is mixing Portland cement down here, and he just creating clouds of dust. And I, as the University Industrial Hygienist, come and monitor his exposure. And I find he's above the limit of exposure for silica dust. I say, okay, Dylan, you got to do some more of this tomorrow. And he'd say, yes. Okay, play along with me here. Help me out. Okay, so your name?
Joseph.
Joseph also mixes Portland cement from time to time. So I say, okay, Dylan's going to work in the morning. You're going to work in the afternoon. We have administratively reduced your exposures. Everybody follow how I'm working with this? Okay, all these, lots of chemicals have exposure limits that are set up by OSHA. And that's where we're using, what we're using to gauge your exposures from. So if I split the job up between these two young men, then I've cut the exposure in half, I'm good. Now, let me ask you a question. Instead of using Portland cement, let's say you're using influenza virus. Would that work if you guys are involved in a lab procedure using influenza? Think about it. Why wouldn't it?
Risk contaminating 2 people?
Yeah. I can say that I can cut your exposure to silica, a solid item, solid contaminant, in half by cutting your work in half. But where 1 or 2 molecules of silica dust, it's not going to affect you a whole lot. 1 or 2 influenza virus may do what to you? Give you the flu. Give you the flu. So I can't cut your exposure to influenza in half. So then we got to fall back on respirators. And I try to make this clear to everybody on campus who has to wear respirators, especially if they're working in research handling pathogen material, biological material. Does that make sense? Everybody with me on that? Have you got a chair? Okay. Okay. Sometimes, if we can have engineering administrative controls, they're not working. Either they're being repaired, replaced, installed, whatever. So again, our respirator protection program is our fallback. And you may eventually need to provide respirators for the people who work for you when you get out in the real world. Sometimes emergency situations. We've got a crew in the Vice President's office who responds to chemical emergencies. The facilities people have a crew that respond to confined space concerns and emergencies. They have to wear respiratory protection and take it with them, like a Scott Air Packet or an airline, because they don't know what they're getting into most of the time. So they take good air with them and they can deal with what's got to be dealt with. All these things have to play into your selection of a respirator, or my selection of a respirator for somebody. Tell you a brief little war story. I got called to an accident when I was in Charleston, South Carolina, at the shipyard, where a gentleman had been painting inside a submarine in the middle of summertime on a day like today, except it wasn't cloudy. It was no cloud in the sky. He was wearing a respirator like the airline one I showed you. He finished painting, crawled out of the ballast tank, got up on the side of the pier, took his air mask off, and immediately hit the deck, passed out, totally unconscious. What do you think was going on? Anybody want to hazard a guess?
Dehydration.
There was some dehydration there, yep. But what else? Hot day, working in the shade, comes out, has a respirator on, blowing cold air on his face. He had an instantaneous heat stress situation because his brain and his body weren't communicating that this was cold, this was not. So he was cold as a fish, cold as a mackerel on the side of the pier, because the demands of his work weren't really taken in consideration by his supervisor, manager, foreman, whatever, to include that possibility that there could be some problem with his using an air-fed respirator. I see some looks of confusion. Anybody confused with that? Okay. Years ago, OSHA let people wear a dust mask to do asbestos removals. But about the early 90s, the research folks for OSHA said, no, that's not a good enough respirator. We got to go to something more substantial, that's better protective, provides more protection for the wearer. So that's why I put this statement in here, that sometimes you need a better respirator for the application. We had some researchers who wanted to go to Belarus last year, do some research on red wolves in the Chernobyl area. How many of you ever heard of Chernobyl? What was the big thing about Chernobyl? One word, starts with R. Radiation. Radiation went everywhere. So when I asked them how they're going to trap the wolves, they said, we're going to dig trenches around Chernobyl. Now, do you think the alarm started going off? If they're digging, not only could they be inhaling dust, but go back to something I mentioned a while ago about your eye protection. Could that be a source of radioactive element exposure by getting some dirt in their eye? Okay. So for those folks, we had to put them in a full face type of respirator to protect not only their breathing, but their eyes. So you need to be aware of possibilities that come up like that. Down here, you might not get that in depth with it. Just real quick, this is what our campus program involves. We know what we're dealing with from historical purposes or reasons, sampling, monitoring, what have you, that sort of thing. Everybody who has to wear a respirator has to have a medical evaluation. So if you as a manager, foreman, whatever, require an employee to wear a respirator, you've got to get them physically checked first. If you just provide them a respirator for their creature comfort, that's a different thing altogether. They still have to know how to put that respirator on correctly. Okay, we'll go through that one. Any questions on respirators?